about the isomerism. Isomerism. Haloalkenes and haloarenes are they exhibit as isomerism. First of all, what is meant by the isomerism? Any one of you? Make it fast.
Uh, Same chemical formulas for different structures.
Very good. So compounds are two or more number of compounds are having same molecular formula but differ in the any one of the physical or chemical property of the compound is called as a isomerism. Okay. And the two compounds are we can call as a isomers. The two compounds are we can call as a isomers and the phenomenon is called as a isomerism. Is it right? Now, actually, how many types of the isomerism it is there for us here? Isomerism is classified into how many types? Ritu, Samhita, Kathy,
Sir, four.
Four.
Two types.
Two types, man. Generally, isomerism is
I
classified
thought
into two
chain
types.
isomerism.
One is structural isomerism, another one is
Geometrical isomerism.
stereoisomerism.
Oh yeah, isn't stereoism also geometrical isomerism?
Geometrical isomerism, it is one of the part of the stereoisomerism. Okay.
Okay, and then optical isomerism is another part.
Yeah, optical isomerism also it is there in this chapter. So important concept is optical isomerism only. Right. So here in this one, so what we are discussing means here. So isomerism. So two types of the isomerism now. One is the structural isomerism, another one is here stereoisomerism. Okay. Again, structural isomerism is classified into how many types and what are the types of the structural isomers are there? Any guess? How many types of the structural isomers are there? Ritu, Samhita, Kathy. We have a different types of
Six.
4 or 5.
Total actually we can get as a six isomers, structural isomers we will get here. What are the six structural isomers means here? Chain isomerism, position isomerism, functional, metamerism, tautomerism, and ring chain isomerism. So total how many isomerism it is? How many types of the isomerism is there under the structural isomerism means total 6 types are there. One is chain isomerism, positional isomerism, functional isomerism, metamerism, tautomerism, and ring chain isomerism. Okay. Now, out of that, haloalkanes and haloarenes are exhibits which type of isomerism? That is my question here. Under the structural isomerism.
So position?
Okay. One is position because of you wrote as a 1, 2, 1, 3, 1, 4. All those are the examples of the positional isomers. And next, position isomerism 1 is correct. Next, what is another one? First of all, compounds are they exhibit as a chain isomerism. Na?
Yes, so chain isomerism and
Haloalkanes are they exhibit as a chain isomerism. Chain isomerism. Anyone of you can you tell me what is meant by the chain isomerism? Anyone of you can you tell me the chain isomerism?
So where the number of carbons in a chain changes, like if one has 6, then in other one could be like 4 and
Okay. So that means here the compounds are two or more compounds are having same molecular formula but differ in their chain length is called as a chain isomerism. Okay. What is the best thing to exhibit as a minimum to exhibit as a chain isomerism? Minimum how many carbon atoms it has to be there?
3.
3 isomers means how it is converted.
4.
Minimum 4 carbon atoms it has to be there. To exhibit as a chain isomerism, minimum 4 carbon atoms it has to be there. Then only it exhibit as a chain isomerism. Otherwise, it does not exhibit as a chain isomerism. Okay. Now, sir, what are the examples means here? As per you told that. So now I'm taking as some 4 carbon atoms. What are the 4 carbon atoms means here? This we can call as a 1, 2, 3, 4 are there. So this we can call as a chlorobutane. Chlorobutane. Okay. So this also we can write as a 1 chlorobutane also we can write. And what is the another structure? Another structure means here. So here Cl you are getting, here one methyl. So this also we can call as a isochlorobutane. Isochlorobutane. So it's not the isochlorobutane here. Okay. So this one correct only. Isochlorobutane. Okay. So how you are telling that isochlorobutane is lost, but one carbon atom is attached with the one methyl group. Okay. So one chlorobutane R. So this also, what is the IUPAC name of this one means here? How we can write means 2. No. So 1 chloro, 2 methyl propane. 1 chloro, 2 methyl propane. IUPAC name of this one is here. 1 chloro, 2 methyl propane. Methyl propane. Sir, we can start the numbering from here. 1, 2, 3. Okay. Chlorine is attached to the first carbon atom. Hence, I wrote as a 1 chloro, 2 methyl propane. So 1 chlorobutane, 1 chloro, 2 methyl propane are the both are the examples of chain isomers. Because of they having the same molecular formula but differ in their chain length. Okay. So hence, what is the next isomerism means here? Haloalkanes or haloarenes are they exhibit as a position isomerism. What is maybe the position isomerism? Position isomerism. So what is maybe the position isomerism? Right, ma'am? Aditi.
So where the position of the substituent group differs, but the number of carbons in the chain remain the same.
Okay. So having same molecular formula, the two compounds are having here same molecular formula, but differ in their position of the substituent. Okay. Now, what is the example we can write as means here? Let us see. We can write like this: 1 chloro, and another one is we can write like this. This one. So, any one of you can you tell me the IUPAC names of the given compounds? Either these two are the examples of the positional isomers or not. First of all.
So first one is 1-chlorobutane.
Okay.
And the second one is 2-chlorobutane.
Second one is the 2-chlorobutane. 1-chlorobutane, 2-chlorobutane are the examples of here positional isomers. Now, why I'm asking this kind of questions means here in examination also what they're asking means they'll give some general formula. General formula. So what is the molecular formula of the here chlorobutane? How we can write the molecular formula? How we can write molecular formula? C4
H9.
H9 or H7?
So H9, right? In alkane.
H9 Cl.
Cl.
So the given molecular formula exhibits the total number of isomers. Or sometimes what they're asking means here, the total number of structural isomers are exhibited by the given molecular formula. So that time total structures means we have to check it out the chain isomers, positional isomers also we have to check it out now. Okay, for that one first we have to know how to write the chain isomerism, positional isomerism and network. Now C4H9Cl is exhibited as a chain isomerism. If it is exhibited as a chain isomerism, means there you got as a 2 structures. Okay, and by the positional isomerism also we got as a 2 structures. 1 chlorobutane, 2 chlorobutane we got as here. Okay, so the total number of structural isomers means chain isomers also we have to add, positional isomers also we have to add here. Okay, so according to that one only we can get as a total number of structural isomers. Okay, now you got the clarity. Positional isomerism means here compounds are having same molecular formula but differ in their position of the substituent. If different in the position of the substituent means the two compounds are we can call as a positional isomers, and the phenomenon is called as a positional isomerism. Okay.
Sir,
Next.
I have a doubt.
Yes, Kathy.
Sir, how did you get H9?
How do you H9 means here? Let us see. You can write the formula completely. Okay. So here I wrote as a line structures now. First of all, terminals are CH3 group. That means terminal, this one is CH3 group. And this one is CH2. And this one also CH2. Okay. And here also it is CH2, it is there. CH2Cl. Now you can calculate, Kathy.
Yes, sir, yes.
Now you got the clarity?
Yeah, sir.
Whenever you write complete structural formula, we'll get total number of carbon atoms and hydrogens. Okay. Now, so it exhibits as a structural isomerism. Under the structural isomerism, haloalkanes and haloarenes are the exhibit as a chain isomerism, positional isomerism. So we can write another example also, positional for the positional isomerism. What is another example I can write means here 1,2 dichlorobenzene. 1,2 dichlorobenzene also we can take as a positional isomers. And 1,3 dichlorobenzene also we can consider it as a positional isomers. Okay. And 1,4 dichlorobenzene also we can consider it as a positional isomerism. So 1,4 dichlorobenzene also we can consider it as a positional isomerism. Got it? Next. Okay. And other than chain and position, is any other isomers are possible? Structural isomers? Is metamerism is possible? Metamerism, tautomerism, ring chain isomers are not possible. Okay. So here metamerism, tautomerism, and ring chain isomerism and functional isomerism also not possible for haloalkanes and haloarene. Haloalkanes and haloarenes are they exhibit only chain isomerism, positional isomerism under the structural isomerism, and stereoisomerism. Under the stereoisomerism, generally we can observe here geometric. What are the under the stereoisomerism, what are the isomers we are going to be study here? Again, stereoisomerism is classified into how many types? Again, stereoisomerism is classified into two types: conformational isomerism, configurational isomerism. Okay. Under the configurational isomerism, again we are going to study the geometrical isomerism and optical isomerism. Okay. Now, so generally haloalkanes and haloarenes are they exhibit as a conformational isomerism also. Conformational isomerism. They exhibit as a conformational isomerism. And they exhibit as an optical isomerism also. Optical isomerism. So this point is very, very important to us in this chapter here. Okay. So what is meant by the optical isomerism? Any one of you? I think so already we studied this one. When I was there, when I'm discussing with about the GOC. That time we already studied about the optical isomerism. Once again, I'll explain. Okay. So what is meant by the optical isomerism? Any one of you? Aditi, Ritu is not there. Samhita was there when I was discussing about the optical isomerism. Ritu, what is meant by the optical isomerism? Kathy is giving answer. Kathy, come on.
Sir, is it DNL configuration?
Very good, very good, Kathy. It is a DL configuration also we can call here, but it's not the
Sir, when light is passed through and a compound, either they superimpose each other or they don't superimpose each other.
Somewhat correct only, Samhita. So here, what is meant the optical isomerism? So when the plane polarized light is passes through the optically active compound, okay, the plane polarized the substance rotates the plane polarized light either the direction, either it may be clockwise direction or anti-clockwise direction. Okay, so how we can define the optical isomerism means here? So optical isomerism is completely experimental based. Point number one. It is experimental based. By seeing the structure, we cannot say whether the given one is exhibit as a D isomer or L isomer. Okay, so optical isomerism is completely experimental based. So what is the instrument we are using for the optical isomerism means here? Polarimeter. Polarimeter. So what is the instrument we are using? Polarimeter we are using. Okay. Now, in this one. Here, what is the optical isomerism means here? When the plane polarized light is passes through the optically active compound. When the plane polarized light is passes through the optically active compound. The optically active compound is rotates the plane polarized light in a clockwise direction is called as a dextroisomer. It's called as a dextroisomer. So dextroisomer can be represented with small d and it represents with the positive sign also. It represents with the positive sign. If the optically active compound rotates the plane polarized light in anti-clockwise direction, it forms as a levoisomer. Levoisomer. So levoisomer also we can represent with the small l and negative sign. Levoisomer also it can be represented with a small l and negative sign. Okay, small d, small l are the optical isomers. Okay, now you got the clarity here, right? So what is meant by the plane polarized light? And what is meant by the optically active compound? What is optically active compound?
So they don't superimpose each other?
I'm asking optically active compound. Aditi, optically active compound. Optically active. Simple. Samhita, you're giving somewhat answer correct only. If you think really deeply means answer is correct. But my question is simple words, how we can define optically active compound?
Sir,
When
I
we
think it should be chiral.
very good, Kathy. The compound has to be chiral. The compound it has to be chiral. What is meant by the chiral? The compound which contains the chiral center. Okay, simply what we can say means here, the compound which contains chiral center. Chiral center. Aditi, what is meant by the chiral? This also we can call a asymmetric center also we can call.
Sure, in a chiral compound, like the carbon has all different substituents attached to it.
Very good, Aditi. Okay, so which we can call as a chiral center or asymmetric center means here, in a compound, the carbon is attached with the 4 different atoms or group of atoms, A, B, C, D. Okay, so what is the simple example means? We are talking about the chiral. In Greek word, chi means hand. So once all of you once we checked out here. So for our hand, all fingers are having same size or different size? All are having different size of the fingers only enough for hand. What are the fingers are there? All are having same size or different size?
Different.
Different size here. Okay. Now the carbon which is attaches with the 4 different atoms or group of atoms is called as a chiral center, or that is only we can call as a asymmetric center also. Why we are calling as a asymmetric center? So recently I had seen one JEE question, asymmetric center. So because of we have a different kinds of the symmetry. Okay, symmetry. What is meant by the symmetry means here? If you divide in any direction, if you are getting as a 2 equal halves means that we can call as a symmetry. Okay, if you are going to divide in any direction, if you are getting as a 2 equal halves means that we can call as a symmetry. Now our hand is there. If you're going to divide in any direction, are you getting a symmetry here? Are you getting two equal halves? When
No,
you
sir.
cut off, no, it is not possible. If you cut in any direction also, you won't get as a two equal halves. If you won't get as a two equal halves, means that only we can call as a chiral. Okay, that is only we can call as asymmetry. Generally, we have four types of the symmetry. Based on this one, JEE questions also they're asking. Okay, so how many types of the symmetry it is? That means we have four types of the symmetry. Plane of symmetry, axis of symmetry, center of symmetry, okay, and so one is here, plane of symmetry, center of symmetry, axis of symmetry, and one more is there. Actually, end-to-end symmetry also one it is there. End-to-end symmetry. End-to-end means from end to another end. If you cut means whenever you are getting as a two equal halves, means that we can call as an end-to-end symmetry also. Okay, plane means if you divide in a plane, for example, cakes are there. Okay, cakes. If you want to get us a more big size cake means here, they placed in a layer. Pastries and not all, if you observe. Pastries. Layers, it will be there inside of the pastry also. Have you seen or not? Whenever you're having the pastry, if you observe, means some layers it will be there. In between the layers, some cream it will be there. Is there or not?
Yes, sir.
Yes, sir.
Okay. So all those are made up based on the plane of symmetry because of their cutting in a particular side. Then only you're getting as two, all are equal ratio only. That they're having the plane of symmetry. And whenever cutting the cake also. Okay. So we can cut from the center means you're getting as two equal halves. Whenever you're getting as a two equal halves, means that we can call as a center of symmetry. Okay. And end-to-end symmetry. End-to-end means here one corner to another corner. One corner to another corner. Exactly end-to-end means you'll get as a that one kind of the symmetry. Okay. And axis of symmetry also it is there. What do you mean by the axis of symmetry means when you cut along with the x-axis or y-axis or z-axis. If you are getting as a two equal halves means that we can call as a axis of symmetry. Okay. And sir, how we can define as a optically active compound means the compound which does not obey any kind of symmetry also is called as a optically active compound. Okay. It is completely asymmetric. It is completely asymmetric. The compound which does not obey any kind of symmetry in all the directions is called as here optically active compound. All of you got the clarity? Okay. Now, so dextro-rotatory, levo-rotatory. Okay. Now we finish here. And based on this one only, some terms are there. Enantiomers, diastereomers, racemic mixture. Again, all these concepts are related to haloalkanes, haloarenes only, ma. All these concepts are related to haloalkanes and haloarenes. Okay. So sometimes they're asking the question. For example, I'll give the question here. Okay. Let's see. First, one question I'm going to give my here. CH3 bond. CH3 bond. CH2 bond. CH. Cl bond. CH3. Now, so this is the question mark here. Either the given compound is exhibit as an optical isomers or not. Either the given compound is exhibit as an optical isomerism or not. Either the given compound is exhibit as an optical isomerism or not. Aditi, Kathy, Samhita.
Yes, sir, it does. Because
Yes, ma'am, because
like the third carbon, sir, it is attached to all the different groups.
third
Like
carbon or second carbon? Third carbon or second carbon?
from left, it's third carbon.
From left, it is the third carbon. From right, it is the second carbon atom. Actually,
Yes,
number substituent has to get as least number. So that's why I'm asking 1, 2, 3, 4. Okay. So 1, 2, 3, 4. Now second
yes, so
carbon.
second carbon, it has.
Second carbon, it has a chiral center because of chlorine. Here, hydrogen. This side C2H5. So this side group is here C2H5. So this one is methyl group. That one is here methyl group. Okay. Now whether the given compound is chiral or achiral.
Chiral.
Chiral. If it is chiral, means the given compound is exhibit as optical isomerism only, na?
Yes, sir.
Okay, hence the given compound is exhibit as a optical isomerism. So this kind of questions are there. And how to which type of question they're asking means, for example, they'll give some molecular formula. The total number of optical isomers. Okay, total number of optical isomers. For that also I had given some formulas. Either you are having did you remember or not? I don't know here. Okay, so generally for that one also I'll give my here some formulas I will give here. So actually, total number of optical isomers can be calculated. When we can calculate it means if the compound is asymmetric. If the compound is asymmetric, the compound is asymmetric. Total number of optical isomers. Total number of optical isomers is 2 power n. What is the formula we are using means 2 power n. Sir, when we can call as asymmetric means terminals are not same. Terminals are not same. So that time we are using as this formula. Okay. In this one, n is equal to number of chiral center. N is equal to number of chiral centers. N is equal to number of chiral centers. Okay. And another one here. Okay. So what is another one means here? If it is symmetrical molecule, it is sir. If the molecule is symmetrical. Symmetrical means it has some symmetry. Okay. And if the terminals are set, simply what we can say means here, if the terminals are same, condition. What is the condition means? If the terminals are same, if the terminals are same, okay, while having even number of chiral centers, while having even number of chiral centers. What is the formula? Any one of you? So 2 power n minus 1 plus 2 power n by 2 minus 1. Okay. So in this one, so 2 power n minus 1, it represents as a total number of optical. So this one it is exhibit as a mesoisomers. Actually, total number of stereoisomers. What is the formula here? Asymmetric total number of stereoisomers. It's not the optical here. Total number of stereoisomers. Total number of stereoisomers. Okay, so generally we can call as a optical isomers also will get, mesoisomers also will get. So what is meant by the meso compound? Meso. Can I give one example for this one? Let us see. I'm taking as a meso tartaric acid. Okay, I'm taking as a tartaric acid. For example, if I take as a tartaric acid. Sir, what is the molecular formula of the tartaric acid means here? COOH bond. Here H, OH, bond, OH, H, bond, COOH is there. COOH is there. Okay, any one of you. So first of all, the total number of stereoisomers. Total number of stereoisomers. How many the given compound is exhibited as a total number of stereoisomers? Options 2, 3, 4, 5. 2, 3, 4, 5. The total number of stereoisomers. The total number of stereoisomers are exhibited by the given compound.
4.
Kathy, Aditi, you are giving some answer.
So is it 4?
It's not the 4, ma.
Sir, is it 2?
Or is it 3?
3 is the correct answer. 3 is the correct answer. Okay, ma, just what I'm telling that condition. First, terminals. Terminals means 2 ends. 2 ends are identical or different? Here also carboxylic acid is there. Here also carboxylic acid is there. What is the condition I told that? While having even number of chiral centers. How many chiral centers are there in a given compound? So this is the one chiral center, and this is also one chiral center only, na?
Yes, sir.
It has a 2 chiral center. In this one, what is the n value? Means n is equal to 2. Now we can substitute this formula, this one here. Okay, so 2 to the power of 2 minus 1 plus 2 to the power of 2 by 2 minus 1. Okay, now, so if 2 to the power of 2 minus 1 means you will get as a 2 power 1. And this one, if you simplify, means you will get as a 2 power 0. 2 power 0 value is how much, ma? 1 only, na? So then 2 plus 1 total is equal to 3 only, na? Total is 3 or not?
Yes, sir.
Now, so to make you confused, in this only they are asking different question. What is the another question they're asking means what the total number of optical isomers are exhibited by the given compound. Total number of optical isomers are exhibited by the given compound. How many optical isomers are there? How many optical isomers and how many mesoisomers are exhibited by the given compound? Already on screen only it is there, ma.
So it's 3, right?
Total stereoisomers, that one. I'm asking individually again. So optical, how many optical isomers are? Ma, optical is 2, Ritu.
Two.
Very good. And meso? How many mesoisomers are there?
1, sir.
1.
1, ma. Very good, ma. Let's see. Formula clearly I'm writing. So 2 to the power of n minus 1 is represented as optical isomers. 2 to the power of n by 2 minus 1 it represents as a mesoisomer. To make you confused, they're asking separately. How many optical isomers are there? Okay. How many mesoisomers are there? Okay. Now, same thing I'll write differently here. So now one more, while having the odd number of carbon atoms. While having the odd number of carbon atoms here. For example, if the given compound is having odd number of carbons here. While having odd number of carbon atoms. Odd number of carbon atoms. Okay. So total number of stereoisomers. Total number of stereo isomers is equal to 2 power n minus 1 plus 2 power n minus 1 by 2. This is the formula. Okay. In this one, 2 power n minus 1 is represented as a, which one? Optical. 2 power n minus 1 by 2 is represented as here meso. Okay. For that one, I'll give one structure here. COOH it is there. H, OH, OH, H, H, OH, and COOH. So my question is, the given compound is exhibit as a total number of stereoisomers, total number of optical isomers, and total number of mesoisomers. That is my question. Stereo, optical, meso. How we can calculate? Any one of you? Which formula we have to use means here? This formula only we have to use. This formula we have to use. First of all, what is the n value in the given compound? N value. What is the n value?
So is it 2 because the second compound has 2 common substituents, like the second carbon.
This carbon, ma, I'll give the numbering 1, 2, 3, 4, 5. Ritu.
So the third one is having like common, right? Above and like 2 common substituents.
Sir,
Yes.
is the n value 2?
So the n value should be 2, right?
N value should be 2.
2.
N value should be 2. Oh, okay, very good. N value should be 2. At N is equal to 2. Then, if N is equal to 2, then what about the total number of stereoisomers? Somebody they're getting doubt here. Somebody they told as a 3.
Sir,
Yeah,
2 optical isomers.
So 2 optical isomers and 1
Sir, 2
meso.
Okay, 2 optical isomers and 1
Meso.
1 meso. But total number of stereoisomers?
3.
3 is the answer. Got the clarity?
Yes, sir.
Okay.
Yes, sir.
So slightly I modified question mark here. Okay. In place of H, I had taken as a some Cl. In place of H, if I had taken as a Cl. Okay. I don't want to change this one here. Finish. Last one. So last one I changed as it's a Cl. It's a Cl. Then total number of stereoisomers and total number of optical and total number of meso compounds. Structure slightly changed.
Sir, there will be no chiral carbons, sir.
No, in this one, 2 only you will get.
Sir, optical will be 4.
Aditi is giving answer. So let's complete Aditi. Aditi, complete your
So
answer
there are
first.
total 3 chiral carbons.
Very
2,
good. N value is
4.
equal to 3, Aditi.
And optical will be 4. Total 4 optical isomerism.
Okay.
Isomers.
Meso, how many are there? Meso, how many you will get?
2, sir.
2, huh? Okay.
2,
Meso is
sir.
Sir.
2 meso and stereo will be 6, sir.
total stereo, it will be 5. And anyone you having doubt in this one? First
No,
one,
sir.
Sir,
second one.
stereo will be 6, sir.
Stereo will be 6 only, ma.
Uh,
Next. Anyone you having doubt in this one? Samviti, Kathy?
No, sir.
No, na? So now you got the clarity, na? Then some other terms are there here. Enantiomers and diastereomers. What is meant by the enantiomers? Based on that one also sometimes.
the optically active compounds which are superimposable.
Superimposable or non-superimposable?
Non-superimposable.
Non-superimposable.
Non-superimposable mirror images are called as enantiomers. Superimposable mirror images are called as non-superimposable only. But if they are mirror images are there, that means here, actually, sorry, correct only. Non-superimposable mirror images are called as enantiomers. Superimposable mirror images are called as diastereomers. Okay. And what is meant by the racemic mixture? Racemic mixture. Racemic mixture. All these points already we studied. What is meant by the racemic mixture means? The substance which contains the equimolar mixture of the enantiomers and enantiomers only. Okay, the substance which contains equimolar mixture of enantiomers. That means here D and L isomers, it has to be equal ratio. For example, 50% of the D and 50% of the L, it has to be there. That mixture only we can call it as a racemic mixture. What is meant by the racemic mixture means here? The mixture which contains 50% of the D and 50% of the L isomers is called as a racemic mixture. And how we can add the definition means the mixture which contains equimolar ratio of the enantiomers is called as a racemic mixture. What is the net optical activity of the racemic mixture? What is the net?
Zero.
Zero. Very good. So net optical activity of
That
the
will be 0.
0. Okay. So net optical activity becomes as a 0. Okay. And Racemization. What is another term here? Racemization. What is meant the racemization? Racemization is nothing but it is the process of the conversion of the enantiomers into racemic mixture is called as a racemization. Okay, what is meant the racemization means? It is the process of the conversion of the racemic enantiomers into racemic mixture is called as a racemization. And resolution, one term it is there. Resolution. What is meant by the resolution? What is meant by the resolution? Do you have any idea? Resolution is exactly opposite to the racemization. Resolution is exactly opposite to the racemization. Okay, it is the process of the separation of the racemic mixture into individual D and L isomers is called as a resolution. What is the resolution? It is the process of the separation of the racemic mixture into individual D and L isomers is called as a resolution. So this is about the isomerism of the haloalkanes, haloarenes. Sir, where we are getting all these points means here chemical properties of the haloalkanes, haloarenes. It is that SN1, SN2 reaction. They're asking the stereochemistry of the products here. Okay. And if you go for the board level examination also, based on this one, sometimes they're asking the exam questions. We have it 2 marks questions. Is it right? 2, 4, 8 marks questions are there. Okay. Sometimes they're asking this, what is the stereochemistry of the SN1 reaction and SN2 reaction mechanism?
Yeah.
And for this one, 2 marks question, directly they're asking, what is enantiomers? What is the racemic mixture? Okay.
Yes, sir, we do have.
So all these kind of questions are there in 2 marks questions also. So that's why everything I explained to you. Okay. And you're having some of the materials based on this one here. So better to solve some questions. And tomorrow we are going to discuss preparation and chemical properties of the haloalkanes and haloarenes. Can I take the class tomorrow? Is it okay?
Yeah, sir, it's fine.
Yes, sir.
Sangeeta, Ritu?
Yes, sir. Can you
Kathy?
make it in the morning?
Morning same time only.
Yeah, sir, it's fine.
Yes,
Yeah,
sir.
sir, it's fine.
Okay. So then if you continue this 2 days, means this chapter is finished. It's in 2 days. Okay?
Okay, sir.
Already more 50% of the chapter is finished. Just we have to study about the preparations and chemical properties.
Sir, can you just send this PDF? Like, I need to
Yeah.
write down the notes.
Now only I'll forward. Now only I'll forward. Okay? So then I'll update in site only. Okay. Then we'll continue in the tomorrow, same time, sharp 10 o'clock. Okay?
Okay,
Thank
sir.
you all. Thank you all.
Thank you, sir.
Thank you, sir.
Enjoy.